Today I'll talk about linearization of nonlinear equation. Then I'll show you how to do linear regression or least square regression. So I'm taking chemical engineering problem and then I'll show you how to do linearization of nonlinear equation as well as how to do the best fitting by using least square technique. Now here is the problem already given here. So an enzyme behaves as a catalyst in a living cell. To represent enzyme catalyzed reaction, the Michaelis Menten equation is widely used. So that is R is equal to A concentration of substrate Q plus by B plus substrate Q. So here R is the reaction rate, S denotes the concentration of the substrate, A is the maximum initial reaction rate, B is a constant given by combination of rate constant. Now table 1 show experimental data of reaction rate versus substrate concentration, assuming that reaction rate can be represented by Michaelis Menten equation. Now data are given, S concentration of substrate data is given and reaction rate is given. Now from this data we have to determine parameter of A and B of the equation by a least square technique. By using this data we have to calculate A and B, and similar by least square technique, and similar things actually we can get if we fit all this data by using inbuilt function polyfit. We can get A and B, that calculate A and B equation from polyfit and plot S versus AR, and finally calculate R at S is equal to 1.6. So what will be the reaction rate at S is equal to 1.6, so that we have to calculate. Okay, now first I will explain how to linearize of nonlinear equation. So this equation actually nonlinear equation. Now we have to linearize this equation. How do you do that? So this is the that Michaelis Menten equation, that is a nonlinear equation. This is a nonlinear equation. Now to apply linear regression, first we have to do linearize the equation. To apply linear regression, obviously we need linear equation. So now first we have to linearize this equation, means make the above equation to straight line equation. So linearize the equation, what we have to do. So if we take that reciprocal 1 by R, so that will be B plus substrate concentration Q by A of substrate concentration Q. Now if we reorganize, B by A S cube plus S cube by A by S cube, so S cube cancel out, so B by A will be there, B by A S cube plus 1 by A. Ultimately 1 by R is equal to B by A 1 by S cube plus 1 by A. So now here R and S data are given. So now this above equation can be represented as a YP is equal to A1x plus A0, that is straight line equation. So means Y is equal to A1x plus A0. Now here 1 by R actually that is Y. 1 by R actually 1 by R is Y, and 1 by S cube is represented at X. Okay, so that is given. Next slide again. So 1 by R, I can take another color. Okay, so 1 by R and 1 by S. So 1 by R is Y and 1 by S as X, and then A1 is nothing but B by A, and A0 is nothing but 1 by A. Okay, so now if we get A1 and A0, so that we can fit that equation as a straight line equation, Y is equal to A1x A0, or if we get A1 and A0, we can easily calculate that A and B. Now to getting A1 and A0, so we have to do the least square fitting or least square regression. Now how do you do that? So now here that data are given, S data are already given, R data are given, so that we have to convert S and R data like 1 by R and 1 by S cube. So 1 by R is like a Y and 1 by s cube as a x. Okay, and we know that that last video I'll show you how to compute least square regression numerically. So here that if we apply the theory, we'll get one matrix. So that matrix is n number of data points, summation of xi, summation of xi square, a0 and a1 is the unknown, and yi summation of yi and summation of yi xi is the b matrix, right? So a matrix, b matrix, and unknown. And if we do a inverse b, so we can easily get the unknown. Now first we have to form the matrix. Now I already did in Excel. So Excel sheet is here. Already I pasted in that PPT. Now here S data are given. Okay, S data are given. Now X is nothing but 1 by S cube. So we have calculated that X 1 by S cube. So that will given 1.00 plus e to the power. It means 1 into 10 to the power 6. So that we are getting, and R data are given. So again that should be converted as a Y 1 by R, and then again again we have to calculate x square, then xy, so that all these data are actually calculated, and then take the sum of x, sum of y, then sum of x square, sum of xi. Okay, now this is the matrix form, so we have to create that matrix. So number of data points, so here 9 data are given. Okay, and that this is summation of xi, so xi is this. Okay, and again this one xi, and this is x square, so that is x square, and then b matrix is that summation of y, so this is summation of y, and this is summation of xi. Now first we have to do the inverse of this matrix, so use m inverse in Excel. Okay, m inverse, so we can get the inverse of matrix. Then if we multiply a inverse with b, so we will get this coefficient. So that is a0 first one and a1 this one. So a0 and a1. So a0 is 41399.73464 and a1 is 16452.73914. Now if we write in that straight line equation, yp is equal to a1 x a0. So a1 already we got, so we just plug this value. So 16452.73914 and 41.399.73464. So we get that, and we know a1 is nothing but here. So okay, so a1 is nothing but b by a, and a0 is nothing but 1 by a. So a1 and a0 we got. So from that a1 we can easily get a is 2.41547 to the power minus 5, and b is nothing but so I think that should be not this, that should be a1 is 16452 into 73914 into a. Okay, so this is wrong, into a, so that we will get 0.397411705. And finally, so R will be, so A and B we have to calculate, means A already calculated and B also calculated. So A is 2.41547 e to the power minus 5, means 10 to the power minus 5, and then B is 0.397411705. Now in the question asked what will be the that R at S is equal to 1.6. Now if I plug S is equal to 1.6, so we will get R is equal to 2.20184 to the power 0.5. So that can be easily do in the Excel or by hand calculation. Now I'll show you how to do in MATLAB. So code is already written here. Okay, now I'm showing one by one. So CLC means that clear the skin. Okay, and then we have to do that clear all. Clear all means if there any variable, so then clear all, and then that display the Michaelis Menten equation. So we can do that. We can see that. So Michaelis Menten equation is R is equal to a s cube by b plus s to the power cube. Then we have to do the linearization. Okay, So I'm putting all this comment here so it can be easily seen in the MATLAB comment window. So linearization of Michaelis Menten equation, so that is 1 by r is equal to b by a into 1 by s cube plus 1 by a. Okay, so then if we that equation line we know, so that is y is equal to a1 x into a0. So so what is y and what is x, what is a1 and what is a0, so that we can easily get. So y is equal to 1 by r, x is equal to 1 by s cube, 1 by s cube, and a1 is b by a0 is 1 by a. Now we can do the display. We have s data and r data. Okay, we have s data and r data that we can show. Okay, so that s data and r data, we can show that s data and r data. So these are the s data and r data. Okay, now we have to make s data and r data as a x data and y data. So x is equal to 1 by s cube and y is equal to 1 by r. So that we can do. So that is, we'll get x and y data. Now number of data points first calculate. So that is one comment. So length x or length y. So that will show the number of data points. Okay, number of data points. It can be easily showing here. Then if we remove that semicolon, so number of data point is 9. Now calculate the sum. Okay, number of data points, then sum of x, sum of y, sum of x square, sum of xy. Okay, so that we are calculating here. So all commas are there. Okay, now if we can form the A matrix, so that is A matrix is this one. That similar thing we got in here, that A matrix 9 1.00 you can see here. Okay, so that is A matrix. Okay, now we can get the B matrix. Okay, so and then we can calculate A inverse B, means slope and intercept. Okay, so this is the B matrix and this is the that slope and intercept. So slope and intercept we can get easily. Okay, so already got that x underscore L. So from that x2 is the slope and intercept x1 1. So in the matrix, first element is intercept, that is a0. Second element, so that x, this one, that first element is a0 and second element is that slope a1. Okay, that we can see here. Okay, and then display the equation. Display equation, Michaelis Menten equation. So that is y is equal to 3.77.76 plus 1644.33x. So that equation we got. Now we know that Michaelis Menten equation. Okay, so from there we can easily calculate what is that A and B. Okay, so that we can calculate. We know that A is equal to 1 by intercept and B is equal to slope into A. So from that A and B we can get ultimately. So Michaelis Menten equation, so we can get there. So that is R is equal to 2.65170 to the power minus 5 s cube by 0.4361 x the s cube. Okay, now from here by using that equation we can easily calculate that R data. Okay, by using this fitting equation and using S data we can get different R data. Okay, so that R data we can calculate. And now we are using polyfit. Okay, by polyfit using degree of equation is 1. By using polyfit we get the coefficient and then slope and intercept we can easily get. Okay, so polyfit x and y data, and 1 is the degree, and then slope is p1 and p2. And again from here also, so we can feed the data, we can feed that line, okay, and then we can easily get that. Okay, so feed that line, so 3771.761644.7.33x. So similar things we get from that by MATLAB calculation, means doing matrix formation, so we get same equation. Even using that polyfit also we get the same equation. Okay, now from using polyfit also we can get a and b, that will be I think same. Okay, so we are getting same result. Okay, so 2.6517 e to the power minus 5, b is 0.4361. okay, now by using polyfit also we can get that r equation, and we also get that r data. Okay, so that we will get, so a is already 2.6516, so Michaelis Menten equation is r is equal to same thing. Now we can plot all this, plotting the data, all this data. Okay, so here I am doing the log plot. Okay, and I can show you how it look like. Okay, so now if we, so here log s and r, so that is the original data, and then log s and r1, so that is fitted line by using MATLAB, and fitted line by using polyfit. Okay, if we run that, we will get, see, this is the curve. Okay, so that fit is perfectly well, we got that fit. Okay, now next is calculate r at s is equal to, calculate r at s is equal to 1.6. okay, so s is 1.6, similar thing, so s is equal to 1.6. now what will be the r? So here r will be, what is the value of r? If we do that, r will be 2.3965 e to the power minus 5. So if you check the range, so here s is s range, you can see here, so s range is that 1.6, s is that here 1 and 5, so range is okay, so you can go in that here, so s range 1 to 5, so 1 r is 1.737 e to the power minus 5, 2423 e to the power e minus 0.5. now in between there should be one, s is 1.6, so whatever we get in MATLAB, so that is same thing, so that is 2.3965 E05, means we get the similar result. Okay, so this is the MATLAB code I am showing how to do the linearization, and then how to apply MATLAB code, how to do polyfit, how to get all this result, how to get the plotting, everything you can do in one code. That's it. Thank you.